Hello everyone. From this video, I am going to start about mass spectrometry, which is the second technique we are going to discuss about the finding the structure of organic molecules. So in previous lectures, I have discussed about the proton NMR or carbon NMR and 2D NMR, which we use to find the information about hydrocarbon skeleton of organic molecules. But NMR doesn't give any information about the molecular weight or molecular composition of organic molecules. So for finding the molecular weight and molecular composition of organic molecules, we use mass spectrometry. So mass spectrometry weigh the molecules, but it is difficult to weigh a neutral molecule since we cannot control to the neutral molecules. So a mass spectrometer works by measuring the mass of a charged ion instead of a neutral molecule, because you can control to a charged ions, but you cannot control to a neutral ions, because charged ions we can control using an electric field. So a mass spectrometer typically drive in three parts. First, something to volatilize and ionize the molecule into a beam of charged particles, because we cannot control to neutral molecules, we have to convert it into ions first. Then second thing, we require something to focus the beam so that particles of the same mass upon charge ratio are separated from all others. The third, we require something to detect the particle of the same mass upon charge ratio. Now first we will discuss about the instrumentation of mass spectrometry. So typically the mass spectrometer has 5 components. The first component of the mass spectrometer is the sample inlet, which brings the sample from the laboratory environment to the lower pressure of the mass spectrometer. The sample inlet leads to the ion source, where the sample molecules are transformed into gas phase ions. Means first we have to convert all solid liquid samples to vapor phase. Third, the ions are then accelerated by an electromagnetic field. Next, the mass analyzer separates the sample ions based on their mass to charge ratio. The ions then are counted by the detector, and the signal is recorded and processed by the data system, typically a personal computer. The output from the data system is the mass spectrum, that is a graph of the ions detected as a function of their m/z ratio or mass to charge ratio. Here we have to note that all mass spectrometer works under high vacuum. As you can see here, this section works under the high vacuum. The reason is we use high vacuum just to avoid the collision between ions produced by ionization chamber and the gas molecules. Gas molecule means gas coming from environment. They can collide with the ions of our sample and can create a problems here. So mass spectrum, we'll see this is a mass spectrum of organic molecules. On x-axis we have mass to charge ratio, and on y-axis we have relative abundance. So the mass spectrum of a compound is graphically represented by plotting mass to charge values of the various ions or molecular ions or fragment ions against their relative abundance, that is intensity, as percentage of the base peak. So the largest peak in this spectrum is called the base peak. So in this spectrum, this is the base peak, which is arbitrarily assigned the value of 100% abundance, while the intensity of other peaks, like these peaks, are represented as percentage of the base peak. And sometimes the molecular ion peak or parent peak itself may be the base peak. Now the peak representing the molecular ion, not any fragment, is called the molecular ion peak. Means the molecular ion peak has the molecular weight of organic molecules. So in general, charge or molecular ion or fragment ion is 1. So mass to charge ratio will be equal to the mass of that molecular ion or fragment ion. That's why the mass of the peak is equal to molecular ion or fragment ion, but it is actually mass to charge ratio. We simply say it mass, but it's actually mass to charge in actual. Now so now we will discuss about the first part, that's a simple inlet or simple introduction system. So before the ionization of sample by ionization chamber, a sample inlet system provides a stream of molecule. Means it converts the sample into the vapor, which goes to the ionization chamber where the ionization takes place. A sample studied by mass spectrometry may be a gas, a liquid or a solid. Enough of the sample must be converted to the vapor state first to obtain the stream of molecule that must flow into the ionization chamber. In cases of gases, the substance is already vaporized. So a simple inlet system can be used. This inlet system is only partially evacuated so that the ionization chamber itself is at low pressure than the sample inlet system. The sample is introduced into a large reservoir from which the molecule of vapor can be drawn into the ionization chamber, which is at low pressure already. To ensure that a steady stream of molecule is passing into the ionization chamber, the vapor travels through a small pinhole called a molecular leak before entering the chamber. And the same system can be used for volatile liquid or solids. For less volatile material, the system is fitted with an oven which can heat the sample to convert into the vapor. We have to note it that care must be taken not to heat any sample to a temperature at which it might decompose, because if you increase the temperature, then stability of the sample, it will decompose, and then we will not get any molecular ion peak or fragment ion peak in the NMR mass spectrum. And thank you very much.